Okay, today we have a fun project. We are going to be recreating these two spirals right here. Now the first thing I tried to count all the lines and it just kind of gave me a headache to try to focus on that. So I just estimated roughly around 90, I think. So here's what we're gonna do. For my code, first I imported the turtle module, and just the I always use the same generic. I will okay, so I copy and paste from a different um saved file because that's kind of a lot to have to write. And another thing I also always do is I put test.speed0 because that will in not instantaneously, but rapidly, produce the image that I'm trying to have my turtle create. It's just sometimes it's super slow to go all the way. So the first image right here, the spiral, it's starting in the middle, and so we're gonna create a definition function. So def shifted spiral. Um, so originally I had it as just spiral, but to show that they're the same exact function, just with this right here, the a plus equals 0.01, um, commented out would be the first one and left in is the second one. So I kept the function the exact same, just so you can tell it's from the same function. Um, So for in range 87, I chose 87. I know I said 90 earlier, but I estimated around 87. But honestly, you could put it with as many lines as you wanted. I had it with 100. I had it with 90. I just tested it out. So the parameters of our shifted spiral are going to be T for turtle, L for length, and A for angle. And we're just going to have in range 87, right? Turn the angle that we specify for the length that we specify. And the thing is, so we're gonna have our length start off as one right here, but then we're gonna want two to continuously be added to the length. So every time the for loop goes around, it will be adding two more to the length. And so for right now, we're gonna comment out the a plus o1, and then we're gonna give the parameters. Okay, and then we're gonna give the parameters to shifted spiral test 190 because we want the turtle to move one unit for the first square and then shift 90 degrees. But then, like I said, for every loop, it's gonna go through and add another two to the length. So we're gonna run our program. And yes, see the speed zero speeds it up a lot. So there we have our first image. Perfect. See, even ends in the same spot. Now for this, since we wanted to show that it was the same exact, here, we will draw both. We want to show that it's the same one, so we are gonna comment out that whole first part, and uncomment out this part. Oops. And like I said, same everything, except this one has an a plus 0.1, which is gonna, so every time the for loop, it'll give an extra 0.1, 0.01 to the angle, and that's what's gonna give it its curvature. Whee! Now, this does look a tiny bit different But the thing is, out of the infinite number of different angles it can be rotated, I chose 0.01 just so it could, so it had a little bit of the curve up like that and curve up like that. I tried 0.02, it was a little bit too much curve. So, without having the exact angle, um, it was a little bit challenging to do. So I can move it to 0.02 and we can run that and see. Same kind of thing. Nice. That's actually it's probably closer. But yeah, same code. The only difference is with this line right here, a plus equals 0.02. And just a reminder, it's not equals, it's being assigned. I just always say equals because it's the equal button. And so we have both of those. Okay, thank you.